All right, hi there. In this very short little section, we're going to look at a very important mathematical thing to be able to do, and that is to recognize that time can be recorded and tracked a few different ways. And being able to switch between the typical hour, minute, second format that we're used to or decimal hours is an important thing to be able to do. Time is sometimes stored as a decimal. In fact, one of the places where you can see this really easily, if you go to a post office, and specifically the La Crosse Public Post Office, when you're at the window, you can see the time clock or the time stamping clock that's in the background. It looks just like the one pictured here, and it tracks the time of day in hundredths of an hour. So it uses a military format where the 13th hour of the day is actually 1 hour past noon, the 12th hour of the day. So this would be a little after 1 in the afternoon. And obviously we can't have 63 minutes, but it means we're 0.63 hours past 1 o'clock. What's the advantage of doing this? Well, the main advantage is it makes the math on hours a lot easier. For example, we know that when you work at an hourly rate and you work 8.5 hours one day, you can multiply that by your hourly rate. Let's say you make $11 per hour, and that gives you your total wage of $93.50. If we left that in terms of hours, minutes, and seconds, perhaps you worked 8 hours and 30 minutes. That doesn't really mean anything until you convert it into a decimal. So in general, treating time as a decimal makes all the computations with time much easier. And hours are often the units that are used. They're typically rounded to the hundredth or maybe to the thousandth if we want to have a little bit more precision. So let's take these 5 times and convert them into the thousandth of an hour. 8:30 a.m. Well, pretty clearly, 8:30 is half past 8. So we could say that that's 8.5 hours. But mathematically what's happening there is we're saying it's 8 hours and then 30/60ths of the next hour, because of course 60 minutes makes up an hour. So we would divide the 30 by 60, and that gives us 8.500 hours. 13 hours, 36 minutes, and 0 seconds. Those are hours, minutes, and seconds. The 13th hour of the day, that's a military format, and so we can keep that and say that we are at 13 point some number of hours. If we take 36 minutes and divide that by 60, that gives us the decimal part of an hour that's passed, and that gives us 0.6 exactly. So we would say that that is 13.600 hours. 1951:00, that's very similar. We know that we'd have 19 point something hours. 51 minutes, given that there are 60 in an hour, becomes 0.85. We want that to the nearest thousandth, so we'll put an extra 0 on there. 19.850 hours. 21 hours, 12 minutes, and 30 seconds. We're going to have to do this in 2 stages. First of all, let's divide those 30 seconds by 60 and find that this is 21 hours and 12.5 minutes. Now we'll take that 12.5 and divide it by 60 and arrive at 21.208 hours. 11:59:59 p.m. That's 1 second before midnight. So first of all, the fact that this is p.m. tells us that it's afternoon, and so we better add on the first 12 hours of the day to find that this is going to be 23 point something hours. Once we hit 24 hours, that's midnight, and we reset to 0. Now, let's take the 59 seconds and divide that by 60. And if we do that, this becomes 23 hours and 59.983 minutes. And now we'll take that 59.983 and divide it by 60 and arrive at 23.9997 hours. But 23.997 hours, when rounded to the thousandth, is going to become 24.000 hours, which in fact is midnight, which is 0.000 hours of the next day. It's within 1,000th of an hour of midnight. Now let's go in the other direction. 6.75 hours, that must be 6 o'clock a.m. And to find out how many minutes that is, we're going to take that 0.75 and times 60 to convert that into minutes. And we end up with 6 hours and 45 minutes exactly, and therefore there would be 0 seconds beyond that. 20.5 hours, well, that's the 20th hour of the day. That's well into the evening. We know that that half an hour will become 30 minutes, and so this is 20 hours, 30 minutes, and 0 seconds. But we want to mark that as being either AM for morning or PM for afternoon. And so if we're in the 20th hour of the day, we can subtract 12 from that, and this must be 8:30 and 0 seconds PM. Okay, 3.510. We're going to take that 0.510 and multiply it by 60, and this becomes 3 hours and 30.6 minutes. But 0.6 minutes, that's going to correspond to some seconds. So we know that we have 3 hours, 30 minutes, and we'll take that 0.6 times 60 again and find that that is 36 seconds. So 3, 30, 36. That must be in the first half of the day since our number of hours was less than 12, and so that would be AM. Okay, you take a minute and do the last two. Take 17.055 and 13.497, convert both of those into hour and minute and second formats, either being AM or PM. Unpause the video when you're done to see the solution. Okay, 17.055. If we take that 0.055 times 60, we end up with 17 hours, 3.3 minutes, which we can call 17 hours, 3 minutes. And if we take that last 0.3 times 60, we'll get 18 seconds. So we have 17:03:18. 17th hour is well afternoon, so if we take away the first 12 hours of the day, we could say that that is 5:03:18 seconds PM. And the last one, 13.497. We'll take that 0.497 and convert it into minutes, and we get 13 hours, 29.82 minutes. We'll take that 0.82 and convert it into seconds, and we get 13 hours, 29 minutes, 49.2 seconds. 13th hour is in the afternoon, so we can take away 12 from that and note that this is 1, 29, and 49.2 seconds in the afternoon. All right, well, we can't talk about the way that computers keep track of time without at least giving a reference to the Unix clock. In the 60s, when computers were beginning to communicate with each other and the need for a standard time so that they could all be referencing the same time standard was becoming clear, the Unix clock was developed. It was a time measure that started at 0 seconds on midnight, January 1st, 1970, and started counting seconds at that moment. And even though that was about 50 years ago, the Unix clock is still ticking. The address is shown here. I'm not going to pull up the Unix time clock because by the time you watch this, the time will be severely outdated. So you should pull up the Unix time clock. It's pretty easy to find. You can go to the address on your screen, or you can simply go to time.is, and when you do that, you can pull down the drop-down menu on the top right and choose Unix time now. So at the moment I'm shooting this video, the time is about 1.5 billion seconds after July 1st, 1970. You should pull up that clock and see what time it is as you're watching the video. But that does lead to one mathematical question we can answer. How much time has passed between these two Unix times? Well, of course, the first thing we would need to do is subtract them and find out what the difference is. And the difference between these two turns out to be 806,200 236. And since the units of unit time are seconds, those are 806,236 seconds. Now, let's turn those into minutes. If we divide that by 60, we get 13,437.267 minutes. Now, if we want to turn that into hours, we'll divide by 60 again, and we get 223.954 hours. Now, if we want to turn that into days, of course, we'll divide that by 24, and we get about 9.331 days. Okay, so that wraps up this short section. You know how to convert between decimal and hour, minute, second form of a number and back again. And so your assignment on Blackboard this time will have you practicing that conversion process.